Hello, everyone. Welcome to another episode of Q&A about history of science and technology. I see we have a whole bunch of questions saved up here, so let me take a look at a few of these. It's a question here from M. Rudo. Do you know about the history of the invention of OCR, optical character recognition? Not a big expert on this, but I can tell you a little bit about what I know of that. I think it was something that really the first systems that worked, I think, were in the 1950s, and they were sort of using early image processing, and was sort of a question of, well, what is an image? Well, it's your kind of, today we might have a 10 megapixel image, then we might have an image that was, at most, 5 or 10 pixels across. And the question was, given that you have sort of black and white squares, a small array of black and white squares, what will be which character does that correspond to? And I think people tried using cellular automata, that is local rules where you look at the color of each cell and you determine sort of an evolution based on the color of each cell. They also tried using early neural nets. And in the end, the early neural nets did okay. And in fact, I think this really started to work in a serious way in the 1980s. That was kind of the sort of early OCR kinds of things. I know Ray Kurzweil had some kind of machine. There were a number of companies that had kinds of devices that were sometimes in the read for the blind type category. Sometimes later there were ones for reading things from checks, but that was the sort of different branches. There's the can you read a font, and then there's can you read handwriting, and things like the NIST, what was previously the National Bureau of Standards, now National Institute of Standards and Technology, made up this very widely used machine learning data set of handwritten digits. That was, I think, done for people who were interested in doing reading handwritten numbers on checks. And I think my impression of what happened is that there just were these software packages that sort of did reasonably successful OCR. How did they work inside? People like me didn't know until quite a long time afterwards that they used neural nets. They used sort of simple versions of neural nets without a lot of neurons, without a lot of layers and so on. Even, I think, perceptron type networks, so just one layer networks, were able to do something. And I think that, I'm trying to remember oh my gosh. I even know the person who did this, my gosh, and I can't remember the name of the company. But there was a company, there were several companies that sort of had kind of magic code that more or less worked. Then there were kind of things like Tesseract as an example of one that became sort of an open source thing. There were a variety of these. And even to today, there's sort of just been a progressive improvement in kind of these trained neural nets for doing OCR. It's kind of it was an early example of a place where things like neural nets actually worked. And I think that the bigger challenge was, doing the digits. There are just 10 of them. Doing the letters of the alphabet, there's maybe, 26 times 2 or something with upper and lower case. Then there's doing the ideograms for Chinese, Japanese, and so on. That's significantly more difficult. And then there's, I think we've built sort of OCR systems that work across all the glyphs of Unicode. Let's say for plain zero Unicode, that's like 65,000 glyphs. That was non-trivial to do. And it's only recently become, I think, feasible. You can make a distinction between, 10 things or 30 things much more easily than you can make a distinction between 100,000 things. Let's see. Aaron asks about, you talk about the history of theories of extraterrestrial life and the search for extraterrestrial life. Well, gosh, it's a that's a subject which is full of weird stuff. So this idea that there might be other sort of civilizations out there, I think people say Giordano Bruno, who came to a very sticky end, was an example of somebody who was talking about sort of other stars and sort of human-like entities associated with other stars and so on. And I think that was, but that as a kind of a thing people routinely talked about, I'm not sure that really emerged. I remember I wrote about this in some notes in New Kind of Science. The concept that there might be sort of people living elsewhere was, I think, reasonably widespread. I mean, or that there might be people-like things elsewhere. I think Kepler, for example, I think was made some comment about how the people on the moon might hang out in the shadows of this or that and make, have caves in this or that place. So that was kind of a thing. And, one of the things that I suppose was informing that was on the Earth, people had gone and done voyages of exploration, and they'd come to the Americas, for example, and they discovered there are people there. I mean, it could have been the case, and that's actually sort of an interesting thing. It wasn't the case that, in the old world, there might have been Homo sapiens, and in the new world, there might have been Homo floresiensis or something. There might have been a different subspecies, so to speak, in a different part of the world. But the fact is that the mixing time for our species is sort of short enough on some time scale that wasn't the case. So sort of the implicit assumption was wherever you go, there are going to be people there, even on the moon, for example. And the concept that there might be sort of other kinds of critters, I think, was not as prevalent. I think that by the time one got to sometime in the late 1800s, and one's got sort of a generation of science fiction of between Jules Verne and H.G. Wells and people like this. I think by that time it was sort of pretty much, well, they're going to be sort of things living on Mars, on the moon, whatever else. To give some sense of confusion, I mean, a famous example was around 1900 when radio had been discovered, and people were, particularly Marconi, sort of early radio magnate, so to speak, had a yacht going back and forth across the Atlantic. And, in the middle of the Atlantic Ocean, he kind of detected on his radio all kinds of funny noises and so on. And he's like, I don't know what this is. Well, Tesla picked up the same kind of thing, and Tesla said it must be signaling from the Martians. So at that time, that was kind of the immediate assumption was there are Martians, and they'll be signaling, and they'll be using the highest tech stuff we have, namely radio. And so that was a kind of an assumption of the time. I think then that sort of, how did that develop? Well, when it comes to life on other planets, when I was a kid, for example, in the 1960s, and the first landers were going to Mars, there was a significant belief that they would find life on Mars. And for example, one of the things that have been observed is that there were changes in color on the surface of Mars, and people thought that was vegetation that was growing and not over the course of time. Now, actually, there was another sort of episode with Mars, a person called de Vaucouleurs, I think, around sometime late 1800s, I think, was maybe even early 1800s, was convinced that, am I getting the wrong person? But anyway, well-known astronomer was convinced that they were seeing canals on Mars. And, it so happened that that was happening at a time when there was lots of canal building on Earth, when sort of canals were the highest tech thing going on Earth. And it's like, okay, we're seeing these lines on Mars. There must be, the Martians must have an even much more elaborate, canal system than we have. I mean, one feature of talking about extraterrestrial intelligence, extraterrestrial life, people often have the thought that whatever we just managed to do, that's going to be the thing that that is going on all the time among those extraterrestrials out there. Now, another example that I remember is Gauss had this idea of, let's signal to the universe that there's lots of clever mathematicians on the Earth. Let's take a swath of Siberian forest and cut it down in the shape that corresponds to the Pythagorean sort of a proof diagram for the Pythagorean theorem. And his kind of assumption was that, well, the Martians will see it, and they'll it's kind of a signal that there's intelligence here on Earth, so to speak. I think, but in any case, by as I say, even by the 1960s, it was not at all clear that Mars would be a sterile planet. And maybe it isn't even totally clear today, but there was a big challenge. For example, when the early Mars landers went to Mars, must be 1960, maybe even 1970, late 1960s, beginning of the 1970s. It was the question of, okay, you landed on Mars. How do you tell if there's anything alive here? If somebody walks up and says hi and starts waving at you, well, then, okay, that's a thing. But let's say that there are microbes in Martian soil. How do you tell whether there is live stuff there? And it wasn't very clear what the answer to that was. And it was something where people kind of they had a variety of experiments. One of the favorite experiments was to essentially feed sugar to the soil and see whether it metabolized. So it's like, feed it. If there were bacteria there, then you would see metabolism happening, see what happens. There was also some strange experiment that I remember from when I was a kid about oxygen 18 versus oxygen 16, different isotopes of oxygen, and seeing how they were relatively kind of picked up by the soil. And I'm not quite sure what that was supposed to show, but it was supposed to be something that, for whatever random reason, seemed to be a unique feature of life on Earth. Now, again, to give a sense of people's view about life elsewhere in the universe, when the Apollo astronauts went to the moon in 1969, there was a whole protocol that was, I think, set up by this guy Joshua Lederberg, who I met a couple of times, who was a microbiologist who was also sort of an important government advisor and things like this. There was a protocol that said we better quarantine these astronauts coming back from the moon for 10 days because they might bring moon bugs back. And perhaps that had been fueled by things like the sort of H.G. Wells' War of the Worlds story with the Martians coming to Earth and then eventually getting wiped out by microbes on the Earth, and also perhaps fueled by some history of sort of Europeans having brought diseases like smallpox and so on to the New World. But it was sort of interesting that even in 1969, 1970, there was kind of this idea that that the moon might have microbes on it. It was a serious idea that was sort of people paid attention to. So anyway, the Mars landers went to Mars, and there wasn't. They didn't find anything alive there. And turns out, looked like that the changes over the course of seasons on Mars were associated with dust storms, not with vegetation. So that became sort of not a thing. So then, well, the other thing that happened was radio astronomy. And so radio astronomy had been kind of developing in the 1950s, maybe even 40s, with people like Jansky, and the discovery that there was lots of radio intensity from the center of our galaxy and things like this. And then sort of a big boost when pulsars were discovered in 1968, sort of a big discovery from radio astronomy. At the moment when pulsars were discovered, the immediate assumption was this must be beacons from extraterrestrial intelligence. But as a matter of fact, one thing was sort of interesting was that from what I heard, actually very close to the time, I was a kid then, but I actually ran into some of the people who were involved in this stuff. And it didn't take long. It took only a week or so before they were pretty convinced, oh, it must be something different, a neutron star or something. There wasn't a serious, oh, this might be extraterrestrial intelligence. It wasn't sort of top of mind kind of possibility for these kind of precise pulses and so on that were coming in. So, but I think around that time, people were sort of getting interested in let's try and use radio astronomy type techniques. I remember there were some people, maybe a person called Cocconi, maybe a person, oh gosh, what was his name? My gosh, met this guy a few times. He'd been, I think, the chief technology officer at HP, at Hewlett Packard. Name's on the tip of my tongue, but I can't remember it. In any case, there had been a sort of small group of people somehow between places like CERN and places like in Silicon Valley, kind of pushing for let's do things with radio astronomy to try to detect extraterrestrials. By the way, another piece of this whole thing was, Enrico Fermi, must have been in the 1950s, talking about what became the Fermi paradox of, okay, we're here on Earth. Where are all the extraterrestrials? They must be out there in the universe. Why aren't we seeing them? And all sorts of kind of questions there. I might comment, by the way. I know that the Soviet Union was also very very involved in questions about sort of extraterrestrial goings on and things like Kardashev and these different levels of civilization and so on, having achieved sort of different energy signatures and so on out in the universe. I think what emerged with people like Frank Drake and then Jill Tarter and so on was sort of an attempted protocol for, okay, sort of how do we detect things out in the universe? How do we detect sort of signs of intelligence out in the universe? Unfortunately, as I say, the mistake every time is to say whatever we just got here on Earth is what must be all across the universe from all those clever extraterrestrials. And so at the time, it was kind of like we've got radio signals, we've got increasingly powerful radio signals and so on. Radio signals must be the thing. And in particular, it must be narrowband radio signals concentrated at a particular frequency, just like, you can turn the dial of a radio or something. They still have dials, I'm not sure if they do, to a particular carrier frequency that will correspond to a particular radio station and so on. This idea that you transmit radio energy by having this kind of very concentrated frequency band and that you amplify within that frequency band, well, that's an idea, but it's only an idea that's relevant to a small period in human history, perhaps 50 years or so. Because increasingly with 5G and spread spectrum communications and so on, it's no longer the case that you're seeing this kind of intense narrowband emission. But nevertheless, back in the 60s, 1960s, when there was sort of a serious effort to the beginnings of a serious effort to kind of prospect for extraterrestrial signals, that was a time when people said, oh yeah, it's going to be, a carrier signal. Everybody's got to use carrier signals. Let's go try and detect carrier signals. Now, one of the things that happened in the US was there was a bunch of funding through NASA for extraterrestrial intelligence. And there was this chap called Senator Proxmire who went after kind of government waste and discovered this program looking for extraterrestrials and kind of mocked it. And it lost funding from the government for a long time. So then there was sort of this private effort at funding. that became the SETI Institute, Extraterrestrial Intelligence Institute, which has gone off and done things that have very little to do with extraterrestrial intelligence. That's a different story. But that was kind of, so that was kind of put a little bit of stopped some of what happened in the US from going on there. There were also other things like the use of the Arecibo radio telescope which sadly collapsed recently, to send a signal out into the universe that was a signal from us that, frankly, if somebody can figure out what that signal is supposed to be of, it's an impressive piece of human decoding, because it's a rather obscure thing. And people had these sort of quotes clever ideas. Let's make it into a two-dimensional image, and let's have it be obvious that it's two dimensions by the fact that it's a sequence of data that repeats, where the frequency of the repeat is a product of two primes, where you'd say, well, it's obvious that you would take those two primes and you would arrange them in an array with, a rectangular array with the lengths corresponding to those primes. It's maybe not as obvious as one thinks. But anyway, so for a long time, the emphasis was on this kind of narrowband frequency detection. And what got built was a lot of very special purpose hardware for doing this. I used to ask, why is this special purpose hardware? We can do fast Fourier transforms now. We can do what was, when I was asking these questions by 30 years ago or something, it was kind of the very early days of being able to think about software radio and so on. Why are we doing all this stuff in hardware? Why are we looking only for these very specific narrowband signals? I think a good answer, I think one of the people, maybe Jill Tarter, involved in this gave me was, which I thought was as reasonable an answer as one could give, is, well, it's something we can do. There's plenty we can't do, but that's something we can do. If it turns out that the signals from the cosmos are encrypted or even encoded like we encode the kind of the things in cell phone channels, well, we don't have a good systematic way to decode those unless we know what we're looking at. And so let's not do that yet. My own view of things, which I won't perhaps go into in too much detail here, is that there's sort of intelligence all over the universe. The issue is that it's just intelligence not well aligned with human intelligence. And it's something where, we can say, well, the pulsar is doing all these complicated computational things, as sophisticated as the stuff going on in human brains. It just is the case that what's happening in your average pulsar isn't aligned with the kinds of things that we recognize as going on in human brains from all of our history and so on. But I think it is interesting that science fiction has covered the whole concept of, first contact with extraterrestrials and so on, has covered it quite extensively. And I think has quite informed the ways that people think about this scientifically. And I think this question of and nowadays, well, I mean, there's sort of the whole astrobiology movement, which is kind of the modern version of sort of search for extraterrestrial life. And a lot of attempts to say, well, what is a signature? If we observe this molecule in the atmosphere of some exoplanet, what does it mean? If we observe, there was a thing recently we were observing, I think, phosphines in the atmosphere of Venus. Does that mean something about the fact that that's a sort of a life-like signature in Venus? Well, depends what you mean by life. If you have, if you've got life on Earth all has a common ancestor, and all life on Earth has RNA in it, which is a very detailed, specific molecule. And the question is, if you find life on Europa or something, and it seems to be sort of singing and dancing, and it's a little millipede that's walking around, but it doesn't have RNA in it, then that's yup, we found life and it doesn't have RNA in it. But if it's some weird little vesicle that has some chemical processes going on in it, and we look at it and it's just a weird little vesicle with chemical processes, and we don't see RNA, we probably won't talk about it as being life. Even if, you can have, it's rather easy to have little oil drops, for example, where you have one big oil drop and it breaks into little oil drops. And maybe the oil drops accumulate more oil, and so eventually they break up again. And it kind of looks like it's a self-reproducing oil drop, but we say, that's not a serious, version of life. That doesn't have all of the apparatus that we associate with life. I mean, my own view now is that kind of a defining feature of life is essentially molecular scale orchestration of things, that in typical chemical reactions and so on, we just have molecules bouncing around and sometimes reacting with each other. But in living systems, we have these elaborate sort of paths and molecules that orient other molecules in certain ways. It's all very orchestrated. And that seems to be, to me, the unique thing about life that is more general than the specifics of life on Earth with RNA and so on. So a little bit of an outline there. I think it's a funny area that has had sort of a whole series of fiction getting ahead of the fact, and then people being confused about the philosophy of the fact, so to speak, of what does it mean for, to really have extraterrestrial intelligence. If, for example, the pulsars were created by this complicated process, but we didn't see sort of, does that mean that they are the leftover beacons of some complex process of this whole giant star doing all its things, and they just left a pulsar, but that's not intelligence, et cetera, et cetera, et cetera. Let's see. Forum asks, what do you think is the most underrated, undervalued scientist in the last 100 years? Someone who has contributed a great deal to society, but has largely gone unnoticed in the public eye. That's a complicated question. I mean, there are plenty of people who have invented things that were potentially ahead of their time, and where those things did not become the seeds that flowered into something significant in science. But yet, if you go back and look, you'll see, yes, they got it. They understood the seed, but perhaps they understood that seed before the world was ready to have that seed germinate. I mean, one example of such a person is Moses Schoenfinkel, inventor of combinators, in 1920, invented this thing that is a very clear version of what we now think of as universal computation, the idea that leads to software, the sort of core idea of computation, so to speak. He invented that. He wrote a paper about it. It's a perfectly clear paper. Nobody understood it. It was something, even today, combinators are a more are a hard to understand but very clean version of sort of core ideas about symbolic computation and so on. But Moses Schoenfinkel was 16 years before Alan Turing and Turing machines and the real sort of flow of interest in computation. Even Alan Turing was for a long time not sort of widely recognized. And, when people started building practical computers, they only then sort of thought about, there's this Turing machine thing that is sort of an idealization of that. I think that it is a complicated thing because there can be ideas that are before their time, but are very cleanly presented. There can be ideas that are before their time where, you go back and look at the paper and you can say, well, now that I know how this works, I can fish this idea out of that paper, maybe. Those are two different things. And I think the number of times when there are things sort of suggested, invented before their time is quite large. And it is, in my own life and times, there are plenty of things I've invented, which I am perfectly well aware are, a very long time before their time, so to speak. And the challenge is to connect them enough to what exists in the world that people can actually engage with them in the present time rather than just, oh yeah, somebody discovers it in 100 years and they say that was really cool back then. It's more fun if you get to see that discovery, so to speak. So, I mean, there are many examples of that in different domains. I would say in a domain like mathematics, it's probably less, maybe happens a little less than some other domains, maybe, because, well, I'm not even sure that's true, because mathematics sort of, there are an infinite number of theorems you could prove, and people kind of go from theorem we prove to the next theorem we can prove and so on, and they build these chains. And there are, the question of whether people discover things and they discover really cool stuff, but nobody cares. I'll give you a couple of examples. So back when Ramanujan was around in the 1910s, he discovered all these cool things about number theory. Not that many people cared about number theory at that time. So many of those things sort of were, yeah, they were slightly visible, but they were not very visible. Another example, transfinite numbers, invented by Cantor in the 1870s, 1880s. Again, it's like people knew about them at the time, but they didn't deeply engage with other kinds of things. And so it was kind of almost like a lost, marooned island in mathematics, so to speak. I think in many other areas, there have been sort of discoveries made before their time. I mean, whether it's Mendel sort of talking about inheritance and nobody really paying attention to that until somewhat later. People like, I don't know, Ada Lovelace talking about the precursors of universal computation in the 1840s, lost for a very, very long time because there sort of wasn't a continuous thread of history at that time in these areas. So, I think there's lots of examples of this. It's the way in which science both has seeded ideas and turns into giant sort of trees of activity. Those are sometimes somewhat separate things. And that leads to the case where people sow the seeds and nobody ever heard of that person sowing the seed. And then later it turns into a giant tree. I'm reminded of another one, a chap called Chicard, who was a friend of Kepler's and who developed a mechanical calculator for Kepler, which one could argue was sort of the first computer of modern times. The Antikythera device from antiquity is our one example of a completely lost kind of art from antiquity, but people won't have heard of these very early computers. Chicard was one, then Pascal, who was known for other things, in maybe 1640 or something, produced another kind of mechanical calculator. And these are things which sort of eventually evolved into the kind of the modern notions of computers and so on, although it took a very long time. Let's see. Well, here's a question a little bit more in my own lifetime. Des asks, why were elite physicists and others reluctant to embrace computers? So I watched that happen, so to speak. So this was in the 1970s. I will say that when you looked at sort of the use of computers, there were a number of physicists who absolutely embraced computers. Fermi was one of them. Von Neumann, who wasn't really a physicist, was more of a mathematician, was another. There were absolutely physicists, very good physicists. Fermi, a great example, who absolutely embraced computers, and managed to get some mileage. Unfortunately, Fermi died, not long after sort of the first electronic computers started to become available to him. There was a general feeling, I think, among physicists that, like every field has a methodology. And if you were a theoretical physicist, you had your books of tables, you had you had these kinds of things. This was the high art of theoretical physics. By the time you were programming a computer, that was something that was delegated down to the people, sometimes literally in white coats, who were sort of tending the actual computer and so on. I mean, I say literally in white coats because mainframe computers had this very kind of druidic kind of way of operating, where the computer was hidden off in some back room, and the users of the computer at best would interact with it by putting card decks into a pigeonhole and getting back a printout of it later. I was excited back in 1977 when I worked at Argonne National Lab in the US for a summer, and they actually let the scientists be in the computer room with the computer right there. It was, we trust the scientists enough to know that they're not going to, press the button that makes the computer self-destruct or whatever. But anyway, that was not a common case. I would say that the general perception was sort of using computers was messy and complicated and didn't relate to the high art of doing theoretical physics. I myself started using computers back in 1973, and I always was very mystified by the fact that more people weren't using them. And it was true that there was a certain degree of kind of, you had to dive into the details a bit to know what was going on. You had to be a babysitter of the computer. It had been the case that most of the time, the people who had built computer systems relevant for physics, for example, it had to be those people themselves using those systems, because things would go wrong enough that it wasn't, there wasn't a well-encapsulated sort of nice user interface kind of thing that would let other people use the system. It was more like, it kept on, doing weird stuff, and you had to be the creator of the system to know what was going on. When I built SMP back in 1979, that was something which sort of began a process of people being able to use it. Now, remember, there was another phenomenon, which was computer time was expensive. It had been the case that there were mainframe computers where you would submit your job, you get the results back. There was starting to be time-shared computers. There were even some on the ARPANET, where the dynamics were a bit different and where there's no good reason physicists couldn't have been just using those all the time, but they weren't. And then in around late 1970s, so-called mini computers, which were things like the VAX computer, which cost like $250,000 in those days, so probably $1 million or so today, were sort of fairly powerful computers that were sort of within the budget of a single research group, at least in a place like the US. And before that, it had really been the case that the computers were only in the budget of a whole organization, a whole lab, a whole national lab, a whole university, things like this. And so that got to the point where, for example, nobody was allocating time on a VAX computer. Nobody was saying, or most of the time they weren't, nobody was saying, oh, you get from this time to this time, or your job is going to be run at this time to this time. It was just like the computer is sitting there and you can, use it. You can use even Unix at that time, was starting to be a thing, and you would just use it. Again, it was utterly mysterious to me why physicists were not using this. But I think it had to do with kind of the self-image and the fact that it was all a bit messy, and that you kind of had to dive into the kind of details. And maybe also there was a certain, you're a programmer, and programmers were kind of staff people who were sort of several tiers down from the physicists, so to speak. Perhaps that was part of what was going on. I think I've traced the history of quite a few of these kinds of things, and I think it's probably the main conclusion is just that, and what really broke it probably for physicists was the release of Mathematica in 1988, when it immediately became the case that the typical sort of theoretical physicist could just read the Mathematica book. It was nice and short, and get an idea of how to do things and just do them on their own computers. And it just worked. And they didn't have to kind of go and find a babysitter for the program. And that was what really sort of broke that dam. But it wasn't until then that things got easy enough for people to use. Now, I have to say, I've seen the exact same pattern in other places, like, for example, in automated theorem proving. Again, mostly it's been done by people who were the creators of the systems and who did babysitting. You know, when I did something in the year 2000 with automated theorem proving, people who were sort of the people in the field were kind of shocked that some outsider could just come in and just use it and discover something interesting. That was sort of unheard of. And, you know, there's been more work done now with proof assistance and so on. Not automated theorem proving has still not, I believe the result that I got in 2000 on the simplest axiom for Boolean algebra remains the only unexpected result ever found by automated theorem proving, as opposed to things where one's just verifying something one already thought was true. You know, I've seen the same thing again a little bit in LLM science, where you're kind of doing things of starting to look at kind of what can we conclude sort of scientifically at a sort of physics level about LLMs, and a certain reluctance to sort of dive in. And yes, it's a little bit messy with GPUs and all those kinds of things to go start exploring different kinds of phenomena. But that's a place where hopefully the physicists will jump in. But it's a place where there's still seems a bit of resistance, like it's a little bit too complicated and messy, not helped by the fact that in machine learning, you know, it is steeped in sort of black magic engineering detail, which is sort of off-putting for somebody who is used to something that's more sort of basic science oriented. It makes it look like, no, I can't conclude anything here. It's all engineering details. RBS is commenting, I saw an interview of Ed Fredkin where he explained how he tried to teach Richard Feynman how to use a Commodore PET computer. You know, I have just been writing an obituary piece about Ed Fredkin, which has been the most difficult obituary piece I've ever written. I mean, I knew Ed for 40 years, and he had many different threads going in his life. He told many stories. Many of them were deeply implausible. Many of them turn out to have at least kernels of truth in them, much more than I expected. And it's been just a horrible, although interesting activity the last few weeks, untangling all of these kinds of things. I didn't talk about the Commodore PET story. I knew about that. Feynman had this Commodore PET computer that, as a matter of fact, he tried to program a cryptanalysis of Rule 30. He and his son Carl tried to program a cryptanalysis of Rule 30. This must be around 1984 or so. But yes, there was some terrible thing that happened. There was a first Commodore PET that somehow the company that they were getting it from somehow imploded and the money was lost. But then a second one arrived and Feynman got into it. I don't think he was that serious a user of it, I have to say. I know Feynman was much more of a theoretical, you know, he had been a human computer during the Manhattan Project and so on. He was great at doing human computation. He was not, did I ever see him actually use an actual computer? I think not. I mean, when I was working on SMP, he was involved in a bunch of design meetings about SMP, and he had many opinions, mostly about what one would think of as UX, so to speak, of, look, I have a mathematical expression, and I can move it around in this way and that way, and I need to be able to sort of point at pieces and do this and that. I think that the reality of what was possible computationally at that time and in terms of sort of user interaction didn't really align with what he thought he wanted. He was very keen on, I'm trying to remember this now. Yeah, he was very keen on these particular tricks. I remember him trying to explain to me things about these particular tricks for doing things like integrals and so on that he had learnt over the course of many years. And it's like, well, that's very nice, but those are great if you're a human. But if you're a computer, you can do much more boring industrial kinds of things. You can just make these very general expressions and try and simplify them and so on. And I think he was much more into, look, I've learnt these particular paths, these particular ways that I do computation as a human, and they weren't necessarily the ones that a computer should use. There's a quote from Feynman. All right, computer disease, anybody who works with computers knows about. Serious disease apparently interferes completely with work. The trouble with computers is that you play with them. That's a funny quote, because the when I was first working on cellular automata and discovering that these very simple programs could do very, very complicated things, I was talking to Dick Feynman about those kinds of things. And I would say that the thing that most shocked him was that his assumption was that anything about things I was discovering, I must have intuition that they were things worth looking at. And he was relieved when he discovered that actually, no, I didn't have intuition that this is what would happen. I just ran experiments to see what would happen. I have to say, I remember we were working on quantum computers back in, must be 1982, I think. I realized that about 6 months ago, I found these printouts that I had from that piece of work, and I seem to have lost them again. It's very frustrating because I have a good archiving system and search system, but these were just printouts of solutions to the Schrodinger equation in a spin chain, and they weren't really labeled. They didn't have anything written on them. They were just, pictures, and maybe with some handwritten sort of identifying information, but it didn't say, spin chain or anything like that. And I found these about 6 months ago, and I was looking for them again, and I can't find them again, but I will, I hope. But that was an example of a project that Dick Feynman and I were trying to do, where he was working things out by hand and I was working them out by computer. I never understood what he did by hand. He never understood what I did by computer. And I'm not sure we ever really managed to reach sort of complete alignment on what the results were, although we sort of concluded things about the difficulties of measurement in the case of quantum computing. But that was a case where very much it was, I was sort of doing things by computer, and he was like a little bit suspicious about, how can you conclude this? It's what's actually going on in the computer type thing. I think actually I'm remembering now that his friend of mine, Rick Field, was a person who did a lot of computing with Dick Feynman on QCD and on the formation of jets in QCD. When you have a high energy quark or something produced, it kind of dresses itself up with lots of other quarks and antiquarks and gluons and so on to produce the particles that we observe, like pions and protons and so on. And Dick Feynman did a whole bunch of work, which I think he did partly as a social kind of thing because he enjoyed hanging out with Rick Field. But Rick did the programming for that, and I was involved in that also. And in one of my less fine moments, I didn't try to apply. I already knew quite a lot about software design at that point, and I kind of didn't apply that to these simulation programs for particle production, which was a horrible mistake because they were kind of messy, and the mess propagated itself for decades in particle physics. And it would have been really great if that had been more cleanly designed. But in any case, it didn't happen that way. But that was another case where Feynman was sort of working with other people who were doing sort of the computing side of it. Memes is talking about Feynman and his time at Los Alamos and personally repairing calculators. Well, they didn't have computers. They had mechanical calculators. They did not have modern electronic computers. That didn't happen until after World War II. Yes, I do recall some stories about this. Back when I was a kid, like places would have, like the school I was at had mechanical calculators, as well as, the sort of portable version was slide rules. But if you wanted more sort of precision, you would use a mechanical calculator, desk calculator. Actually, when I got to Caltech in 1978, they still had, in the sort of theoretical physics area, they still had, it was rather charming actually, they still had these devices that were kind of sort of built into almost to the furniture, that were kind of calculators, electronic, that were pretty big objects. I mean, I have to say I didn't use one because by that time pocket calculators existed, but they were things, I don't know exactly when they were from, I think sometime in the 60s, that were sort of simple electronic calculators that must have been made with very early microprocessors. They must have been right in the couple of years before 1972, 1973, when pocket calculators, battery-operated calculators, came into existence. Let's see. Question here. This was a question from Des about the early 60s in the Soviet Union and proto-internet. I do not know about that. I think it's very, very unlikely, because in the Soviet Union, photocopiers were a horrible idea as far as the government was concerned. And, to operate a photocopier, you had to have a special license. And actually, I was just remembering a bunch of stories that Ed Fredkin, we mentioned before, told me. And I was organized enough that I did a piece of oral history with Ed Fredkin back in 2014. So I have the transcript of that. And quite a lot of that was actually about the Soviet Union and about his interactions with it over computers. But one of the things that he at least claimed there was that, and one thing I know to be the case, is that photocopiers, like printing presses in the Soviet Union, were things that were very tightly controlled. And, Ed's claim was, a member of the Communist Party had to read any document that was going to be copied on the photocopier, so to speak, and it had to be sort of specifically licensed kind of thing. And so the idea that one would have kind of a free-flowing sort of flow of information, I think was very, very unlikely that was a thing seriously considered there. It may have been a thing considered as part of the military sort of organization. You've got to remember, in the US, for example, and I was just kind of relearning some of this stuff in connection with this obituary I was writing for Ed Fredkin. One of the big projects was a thing called the SAGE project. This is from the mid-1950s. It was, so the SAGE project was an air defense system in the US. And the problem was, well, let's say you've got radars all over the country. You've got radars that are detecting, a Soviet bomber has just entered American airspace over, Montana or something like that. I got to know my geography. Is that border Canada? I'm not sure. But anyway, let's say North Dakota. I think that. Let me not embarrass myself by getting my American geography wrong. Minnesota, that's one that definitely is on the border. A bomber has just entered the US there. Okay, we got a radar somewhere there. How do we get global control? How do we get a global picture of, what's attacking the US, so to speak? And so there was this giant project created to make a kind of coordinated air defense system. And the idea was at that time to use telephone lines and to have these local radars to aggregate the data through telephone lines and bring it all to a big computer that happened to be in Massachusetts at that time, and sort of coordinate the signals from all these radars with this big computer. And so kind of to give you a sketch of the times, I mean, AT&T was going to provide the phone lines, provided the phone lines. This project happened. This project was kind of the most expensive sort of technology development project that had been to date, more expensive than the Manhattan Project, for example. And it was it was a thing where so AT&T provided the phone connections, IBM provided the computers. It was the biggest computer company. Rand Corporation provided kind of the programming side of things, and that was and then these things was all sort of being aggregated together, and so that was in the US sort of the first form of, I would say, sort of coordinated communication between computer-like things was probably the SAGE system, and that was I was back in 1956 when Ed Fredkin learned to program. He did so as he was in the Air Force, and ended up being one of the sort of first cohort of the first 100 programmers, basically. And the SAGE project, they estimated they needed gazillions, hundreds and hundreds of programmers. They were going to write 100,000 lines of code, and they needed hundreds of programmers. They didn't have those programmers. They had to sort of urgently train a bunch of people to be programmers. So, you know, from, I suspect, that network eventually emerged the ARPANET. And that was emerging late it was 1960s by that time. I mean, it's worth remembering that kind of that air defense system became, you know, it's in like the Dr. Strangelove movie. There's a big sort of board showing, you know, planes attacking. I think that was attacking Russia in that case. But you know, the fact that you could have a coordinated display of all these things was far from trivial. The concept that you know, this eventually became the thing that, you know, NORAD got centralized in Cheyenne Mountain and so on, where it's kind of like, you know, dug underneath the mountain to withstand kind of nuclear attack. I think I'm told the highest technology part of that is the giant sort of spring on which all the computers and so on are you know, everything there, the facility is sort of on that, so that even if sort of there's a giant kind of seismic event produced by all kinds of atom bombs or whatever, that it still doesn't disturb the running computers. I'm not sure that's so much of an issue these days. In the original version of this, it was all vacuum tubes, which would have been deeply disturbed by having been sort of knocked around. I mean, it used to, I don't even know these days, you know, the typical laptop computer does not, you know, withstands, you know, G-forces quite well. Now, I'm pretty sure it's still the case that insofar as there are any moving parts, like disk drives, they have accelerometers that retract the heads for the disk drive if the thing feels that it's falling and is about to, you know, have a high acceleration event. But I think, I think actually Ed Fredkin claims to have been very deeply involved in the kind of introduction of PCs into the Soviet Union. And this is 1984 type timescale, a very bizarre series of events. I mean, really quite hard to make this stuff up. But essentially, the Ed and other people were certainly aware of the fact that the presence of PCs would allow the possibility of sort of information flow outside of kind of government channels. And they saw that as being a thing that was kind of a bring American values to Russia type thing, and sort of a way of injecting that into the Soviet Union, perhaps to the detriment of the then system in the Soviet Union. But there was kind of Ed Fredkin ended up giving this talk at the Kremlin, sort of extolling the virtues of PCs and trying to get sort of enthusiasm about having PCs in the Soviet Union. But the problem was the US had export restrictions on PCs, this thing called COCOM, which was this export kind of embargo on all sorts of technology. And so it wasn't obvious that one could get, you know, PCs exported from the US to the Soviet Union. There were very detailed constraints on exactly what attributes the PC could have if it was exportable and so on. But in something that I didn't really know had happened, even though I knew Ed at the time when this was going on, is that there was this physicist, Russian physicist named Andrei Sakharov, who actually did a lot of interesting work in things like cosmology, but had been involved with the Soviet nuclear program, was a major figure in the Soviet nuclear program, who became kind of a Soviet dissident, and who was at that time in all kinds of craziness, in sort of internal exile in the Soviet Union, and I think was even sort of on hunger strike and all kinds of terrible things. This was sort of viewed as a humanitarian crisis of some kind, and there was kind of a lot of pressure for, release Sakharov type thing. And so Ed kind of conflated that with the story of PCs and so on, and was trying to get the Soviet Union enthusiastic enough about getting PCs, then talk to the US about using sort of PCs for Sakharov type deal. And actually, I found in the Reagan Library, there are documents, there's actually a whole file about Ed Fredkin and computers in the USSR. And it's quite interesting reading. I mean, it got, there are things like memos where George H.W. Bush, who was vice president in those days, was, on the phone with this person who was the daughter of Sakharov, talking about, Ed Fredkin going to the Soviet Union and trying to convince them to have PCs, and whether that was something that would be kind of a deal that the Soviet Union would go for in that regard. And Ed had a whole scheme where he would go talk to Sakharov and so on. None of that actually happened. And the US kind of dragged its feet on this, on approving the export through what was then Fredkin Enterprises of PCs to the Soviet Union, but some got exported, and then lots more got exported in subsequent years. But so that was that was sort of the introduction of PCs into the Soviet Union, was something that happened. It kind of happened in that rather bizarre way. I have to say, I was just remembering, I visited the Soviet Union in 1987, and going to some conference. It was a very Soviet kind of conference. It was about logic, methodology, and the philosophy of science. And it had, in those days, you would go to, you'd go there, and they would have a certain number of, cosmonauts with huge numbers of, wearing very large numbers of medals and so on, who would kind of sit on the stage, generally adding gravitas to the whole affair, but typically not saying a word. And and they also would have kind of the flavor of the time. They would have all of the simultaneous translations. So sort of half the audience would be wearing a headset, where there would be this translator in some booth somewhere who was translating between Russian and English and so on. And I think perhaps, in the flavor of the time, so to speak, when you went to the Soviet Union in those days, everybody would get assigned some kind of guide who was basically a handler and you could only go to a very restricted set of places. And my handler was a chap who, I don't wonder if I knew his name. I don't know. Who was fairly young chap, spoke rather good English, and although claimed to have never been to the US or any place that was an indigenous English-speaking place, was telling tales of woe about how broken the Soviet Union was. I remember him saying, they had a refrigerator factory that for 7 years had made all the refrigerators they made, none of them had ever worked. And it was not a good advertisement for the communist system, I have to say. But, and then he had a whole tale of woe about this COCOM export restriction thing, and how it was sort of destroying the potential of the Russian people and all this kind of thing. But it was just asking me all these questions about the American computer industry, which I was mostly kind of being a bit vague about. And eventually, because I wasn't really, it's one of these things where it's sort of there's a complicated line between what is proprietary information. I've never had a security clearance, so I don't have to worry about that. But it's definitely many questions being asked that were. I was pretty involved in the computer industry by that point, and I knew a lot of stuff that was sort of coming and not really not stuff you could read in the newspapers yet. So eventually, I just asked this chap, well, okay, you're asking all these questions. Tell me, what do you actually want to know? And what he said was sort of interesting. It was in those times, the Soviet Union had successfully cloned the Intel 8086 microprocessor, and they were wondering, should they clone other microprocessors, in particular the Motorola 68000? The question was, maybe I went there a couple of years earlier than I'm saying, because that it seems too late for that question. Anyway, never mind. But the question was, maybe they were, just a bit delayed in asking that question. The question was kind of, was the Motorola 68000 worth cloning? There are going to be a lot of software manufacturers who are going to produce software for that. See, the playbook had been that, for example, the Soviet Union cloned the IBM 360 mainframe computer, and their idea was that there'd been all the software developed. If they could just clone the hardware, same idea as a lot of American computer companies followed in subsequent years, if they could clone the hardware, they wouldn't have to rewrite the software. Ed Fredkin actually tells a story told me a story about being involved with that. The project was called RIAD, that was in the Soviet Union for cloning the IBM 360, that apparently had fallen upon hard times, and was eventually the whole thing was imploded, and just that's a separate story. But the chap who was talking to me was interested in, should they clone the 68000, the Motorola 68000, and then there was a whole kind of tale of woe associated with the fact that the 68000 apparently had a layer of epoxy on the surface of the microprocessor that was hard to get through. Presumably on the 8086, you've been able to basically just get an electron microscope or maybe even an optical microscope and look at the circuit pattern and be able to sort of clone the circuit pattern. But on the 68000, it had a layer of epoxy that made it hard to do that, so he said. He was convinced that that was there because the US government was trying to prevent Motorola from letting the Russians clone the 68000 and so on. And I said, I really doubt that that's the case. I think it is vastly more likely that it's there so that Intel will not clone the Motorola 68000. And he had a very hard time believing that. That was it's just a kind of commercial competition like that was not a thing that was the same kind of known thing in the Soviet Union at that time. So it was something that was hard to understand. Let's see. Paula asks, how do you think kids today would react if they were suddenly teleported 40 years into the past? Boy, they'd be looking for their phones. And what would they do instead of phones? They would discover that that kids were allowed to do all kinds of crazy things that nobody allows kids to do anymore. I think they would, 40 years ago, that's early 80s. That's modern times. I think it's funny, when the pandemic started, I was noticing that suddenly I started seeing all these people, all these families and so on, walking around outside. And, that hadn't been happening before. It's kind of like when sort of there's a change to the environment and people can't go and hang out wherever they were hanging out, they kind of change and absorb other kinds of things. And my guess is that that's what the typical kids of today, transported back to a pre-phone time, would end up doing. And they would, 40 years ago, there were VCRs, weren't there? Yes, I think so. Yeah, I think there were. There was most definitely television and so on to watch. So I'm not sure that they would have it. It would be too traumatic. I think they might actually do just like the people going outside and walking around at the beginning of the pandemic. They might just go hang out with more actual kids in person, rather than only kids on social media. All right, maybe one more question here, and then I should wrap up for today. Jamie actually asked the question, it's kind of interesting. Have aliens always been referred to as aliens? Did they have another name in history? I mean, people talked about them as Martians, for example, in the time of War of the Worlds and so on. In the that was a typical kind of name. The concept of the generalized extraterrestrial intelligence, I think the term alien is of quite recent vintage. I think that's not. I'm trying to think. I mean, even if we think about science fiction cases, does Star Trek use the term alien? They talk about, in the new life and new civilizations and so on. It's interesting now that I think about it that they say new life and new civilizations, when obviously if they're discovering civilizations, those civilizations have been around for a while. It's kind of like the discovery of America, so to speak. It's a new civilization in the same sense that America was newly discovered, so to speak. I hadn't noticed that before. But I don't think that they refer to things as aliens. I think they refer to them as life forms and so on. I don't think that's the mid-1960s. I don't think they were using that term at that time. So I don't know exactly when that came into common use. I think it might not have been until the 80s or even the 1990s. Let's see. Well, that's an interesting question from Jamie. Have there been any observable changes to planets during the time humans have lived on the Earth? Yes, the red spot of Jupiter has changed. I mean, that's the red spot is a big storm that's been there for 400 years or so, but it hasn't been there for all of human history. But I guess you need a telescope to see the red spot, so that doesn't count. There weren't telescopes until 1605 or 6 or so. Let's see, of things that visible to the naked eye, I really doubt it in the time of human history. But that's the only one I can think of, but it would need a telescope to see it. Yeah, that's the only one I can think of. Oh yes, that's interesting. Des is commenting, there's a Catholic history of discussing ETs that were neither human nor angels. There's a theological field called exo-theology. That's interesting, because certainly the Catholic Church was not in the 1400s, 1500s and so on, was definitely not into the concept of civilizations other than us humans. So I don't know about more recent times. Let's see. There was a question here which I'm wondering about, which is someone asked here, uh, um, um, oh yeah, Philip asks, what is the oldest book that you actually use that is not a museum piece? I have a whole bunch of antiquarian books, and I've definitely looked at them for sort of non-museum purposes. I would say that there's certainly books from the 1800s that I've routinely looked at in sort of in a non-museum kind of way. The typical pattern is, there'll be people like, let's say, Isaac Newton, where there's a famous book or two, and those famous books will have been reprinted continuously over time. But then there are obscure books that were never reprinted. So, for example, in the case of Newton, the famous books like his Principia Mathematica from 1687 reprinted over and over again. You can get, on the internet, there's a copy of it. You can get sort of paperback versions of it all the time. But if you ask about his Chronology of Ancient Kingdoms, which was the last book he wrote in his life, that hasn't been reprinted, and I have a copy of that. And although it's not something in that particular case that I've particularly referred to, I've looked at it. And that's a thing where probably in modern times, I'm sure the Internet Archive, for example, would have a scanned version of that book. It's deeply out of copyright. But that's a thing where it might be convenient to look at it. I mean, for example, there's certainly books from, I'm trying to think here, like yesterday I looked at a book, not very old, 1961, that was, that actually I was wondering, I found a copy on the Internet Archive, but it was kind of a nuisance to flip through it all. And I'm thinking, I think I have a copy of this book. Yes, I do. Okay, it's right on my shelf. I'm trying to think of other kinds of things that are of that character. I mean, as I say, somehow the minor works of major figures, if you look back at kind of, I would say, back to probably the 1930s, there are like a bunch of math books and things like this. Oh yeah, here's an example. I have a pretty complete collection of the proceedings of the International Congress of Mathematicians, which happens every 4 years, and it's been happening since the late 1800s. I've absolutely looked at versions of that from around 1900 and so on. I've looked at things like the works from people like Ramanujan from that time. Oh, and another one is Principia Mathematica of Whitehead and Russell, which is from 1910 or so. I've certainly looked at that. I have, maybe I only have the second edition of that, which might be from 1914 or so. Other things, there are a bunch of books from the early part of the 20th century that I've absolutely used for that purpose. And I think of older ones, so there are other ones where I have certainly been curious about them and have looked at them. I wouldn't necessarily say I've used them for reference, so to speak. As I've been working on kind of this idea of symbolic discourse language, this kind of way of representing meaning without having an explicit known human language, so to speak, more like our computational language. There are a bunch of works from the 1600s that mostly the ones I've looked at so far I have sort of facsimile copies of, but some I think I'm going to have to go back and dive in and look at the originals, because I don't think that that anybody bothered to make facsimile copies of them, because people didn't think anybody would care about this stuff. So I think these works that are more on the studying sort of philosophy and linguistics kinds of things, there's probably some older stuff there that one, it's worth looking at, so to speak. It's always an interesting question. If you look at the literature of particular areas of science, what the kind of decay time is. there's some fields of science like medicine, for example, where, if you're referring to papers that are more than 5 years old or something, then people think you're writing stuff that doesn't make any sense. In mathematics, for example, there's a bit of a longer tail. People, you might refer to something from 100 years ago, and that might be sort of okay. In physics, very unlikely that you'd be doing that. Physics, it's more like maybe 20, 30 years, something like this. And different fields have different sort of decay times. If you're doing philosophy, you might routinely refer to Plato, and that's a 2,000-year span, so to speak. So different fields have these different kind of decay times that a certain amount of study has been done of. But whether you need the original book is a question of whether that book, by the time you're getting to things from antiquity, you're obviously not going to be looking at the original book because none of that has survived. And anything that has survived is sort of a reprinted thing. And I think the earliest books I have come from, maybe I have some from the 1500s. I'm trying to think there, yes. But certainly a bunch from the 1600s. But most of those, as I say, are no longer kind of in currency in terms of their content, except maybe some of these things that relate more to philosophy and linguistics and so on. All right. Well, I should probably wrap up there. Thank you for a bunch of interesting questions, getting me to think about a bunch of things that I don't usually think about. So I appreciate that. And I look forward to chatting with you all another time. Bye for now.